Hey, algebra, let's make our answer key for the homework. We got Unit 8, Lesson 10, and we are learning how to solve equations that have square roots in them and to write them with these like little plus or minus signs. So we saw that like, if we have the square root of 25, we know that 5 times 5 is 25, or negative 5 times negative 5. So we've been writing that as plus or minus 5. Now, what if we had the square root of an ugly number like 40? Well, that's one of those things where we're allowed to write that we know the answer will have a positive, whatever the square root of 40 is, and a negative, whatever the square root of 40 is. We also learned on our calculator how to like find that little square root function. It's here, it's in blue, it's above this button, so we need to hit second, and then we need to hit that button to get the square root symbol, and then we could type in the square root of 40. Now, closing the parentheses, that then locks in what is underneath the radical sign. That is a thing that we should do, and we hit enter, we get 6.324. So here's the thing, is that's the approximation of what this is, that this is about plus or minus 6.32. All right, blah, 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 blah. Move on. So this is the exact answer. So, it says match each expression to an equivalent expression. So let's see, negative 4 plus or minus 1. So that's going to be negative 4 plus 1 or minus 1. Okay, so if we add 1, that'd be a negative 3 and a negative 5. So do we got that somewhere over here? Negative 3, negative 5. There, look at that. A matches with that one down there. The root of 4, so here's the thing. The square root of 4 is equal to 2, or negative 2. So we'd either have 10 plus 2, which would be 12, or 10 minus 2, which would be 8. So 12 and 8, we got that one right here. B matches with that. Zoom in just a little bit. All right, 6 plus or minus. So this is just a little exercise in how do we interpret this. So negative 6 plus a positive 11 would be let's see. So if that was, they're opposite signs here. So it's kind of like 11 minus 6. So just like looking here. Yeah. So we would end up getting 5. And negative 6 minus 11 would make negative 17. That's even further into negatives. So C matches with that first one. And here. So this is one that finding the root of 10 isn't so nice. So 4 plus the root of 10 and 4 minus the root of 10 is another way that we could write it. 16, well, the root of 16 is 4. And then we'd have plus or minus the root of 2. So 4 plus root of 2, 4 minus root of 2 is equivalent to the last one. Let's move on. And by the way, we could also, for these that have the roots in them, we could also type on the calculator the square root of 2 and add 4 to it, or take away the root of 2 from 4 to get the decimal equivalents of these. All right. Determine the exact solutions to each one. Write the solutions with the plus or minus notation. Okay, so we see x squared is equal to 144. That's easy. We're going to take the root of that. That would be 12. But x would be equal to either positive or negative 12. Okay, same thing here. Take the root, but x would be equal to a plus or minus the square root of 5. All right, whatever the root of 5 is. Again, we use our calculator to type in the square root of 5. Here, we want to divide by 6 first. Divide by 6. 42 divided by 6 is 7, and we get x squared is equal to 7. So some number squared is equal to 7, and we solve that by taking the root of that, and so x would be equal to plus or minus the square root of 7, whatever that answer is. All right, again, we could take our calculator and find the square root of 7. It would be a positive 2.645 or a negative 2.645. But we can write it like that, and that's the exact answer. No rounding needed. All right, this one, let's add 25 and add 25. Okay, so we got, 4 times something squared is equal to 25. Okay, well, that's kind of nice. We'll then divide by 4 and divide by 4. Here, I'm going to take you down a little road here. We get x squared is equal to 25 over 4. We didn't talk about this in class, but here's the thing. When you take the root of this, when you take the square root of a fraction, you can take the root at the top and the root at the bottom. That's kind of cool. So what we get with this is we would get the square root of 25, which is 5, the square root of 4, which is 2. We get 5 halves, but it would be plus or minus that answer. 5 divided by 2 is 2.5. So we could say x is equal to plus or minus 2.5. I love that. You know, this is one that's like, it's a little shooting star problem, a spicy problem that we didn't get to do in class. I like that. And when we could leave that division of these perfect squares so that when we take the root of them, they're nice numbers. You know, again, on our calculator, we could take 25 divided by 4, and we get a number, 6.25. And then we could take the square root of 6.25, and look at what we get. We get 2.5. 2.5, plus or minus 2.5. Same answer, just a different way of logically getting there. One without a calculator. All right, so here, want to square root this. We get plus or minus the root of 7 is equal to x plus 4. And we're going to take away 4 from that and take away 4. So here's the thing. We're going to have negative 4, and we're either going to add or we're going to subtract whatever the root of 7 is. And that's what x is equal to. This is our learning target for the day. This is like what I would hope you would be able to do. Now let's look at the next one. Before I undo this by square rooting, I want to divide by 5. 30 divided by 5 is 6. So I get x minus 4 squared equals 6. Now I'm going to take the root, and I get plus or minus 6, but then I'm going to add 4. Here's the thing. I know my answer is going to be equal to 4, that 4 that I'm adding over here, plus or minus the root of 6. So one answer will be taking 4 plus the root of 6 and 4 minus the root of 6. That's our set of answers. And we move on to the last one. Well, okay, let's see. How do we get rid of that 4? I'm going to take away 4 and take away 4. We get 5. Okay, so we get 3 plus x squared equals 5. Don't worry, they switch spots. That's okay. We're now going to take the root of that, and the root of that, we get plus or minus 5. So we get 3 plus x equals positive or negative root of 5, whatever the heck that is. And now we're going to take away 3 and take away 3. Now we're taking away 3 from this. That's like adding a negative 3. So x is equal to a negative 3 plus the root of 5 or minus the root of 5. And we're done. Now that's all I asked you to do in class. I will look at number 9. It says, Adrian says the two solutions to this can be represented as that. Substitute each solution to your original equation to show that it makes sense. Whoa, what are they saying? They're saying take 3 plus or minus the root of 2. So they're saying take this, 3 plus the root of 2, is make that our x value, minus 3 squared equals 2. They're saying take that, or take 3 minus the square root of 2. Put that in for x. And then subtract 3, and then square it, and we'll get equal to 2. Let's do the math on this. All right, so here's the thing. I got a plus 3 and I got a minus 3. Those cancel out, and I'm going to have the square root of 2 get squared. Well, what is the square root of 2? Well, it's the number that when you multiply it by itself gives you 2. And so if I then multiply that number by itself, I'm going to get 2. This one, it works. When I square the square root symbol goes away on the side. I'm left with 2. I'm left with 2 equals 2. Same thing happens here. We got 3 minus 3. And we're going to square the negative root of 2. Sorry, I miswrote that. But when you multiply a so this is saying take negative root 2 times negative root 2. And will that be equal to 2? It will be, because what's a negative times a negative? It's a positive. And what's root 2 times root 2? It's 2. We got the same answer. So there is a little proof that, like, even if we substituted it in, it would end up working as a solution. And so it is a solution. Yeah, that's all we'll go over for class. Take care, folks. Bye.